Hello friends, so this is day 19 for solving problem of the day from GFG. So let's look at today's problem. Okay, so this is a next letter element problem. So given an array of size n having distinct elements, the task is to find the next greater element for each element of the array in order of their appearance in the array. Next greater element of an element in the array is the nearest element on the right which is greater than the current element. If there does not exist the next greater element of current element, the next greater element of the current element is -1. Okay, so let's see the question with an example. It's very easy problem, not so much difficult. Okay, so I've given this array. Okay, so what we have to do is we have to return a same size array. We have to return a same size array. Okay, so this is an array of size 4. I have to return an array of size 4, where suppose the elements are x1, x2, x3, x4. And what x1 represents is the next greater element of 1 actually. Okay, so after 1 in the array, after 1 the greater element than 1 is 3. Okay, yeah, 2 and 4 are also greater elements, but exactly after 1 the next greater element is 3. Okay, so actually x1 is 3. What x2 represents? Next greater element of 3. So after 3 there is 2. It is not greater than 3. Okay, so it's rejected. So after 3 there is 4. Okay, you have to check all the elements after 3, which is the first greater element that I have to be placed here. Okay, so after 3 we got 2, which is rejected. Then we got 4. So 4 is greater than 3. So x2 will be 4. Now what is x3? Next greater element of 2. So after 2 there is only one element. It is greater than 2. So for x3 the answer is also 4. And for 4 the answer is -1. Okay, so actually for every array the answer for the last elements is actually -1 always, because after that there is no element. So if it has no element the answer is -1. They told so in the question they have said this, right? So this is a pretty simple problem to understand. Let's take another example. Okay, let's take another example, then we will solve the problem. Suppose 10, 30, 0, 24. Okay, so let's check. So after 10, 30, right? So here what will be placed here? The next greater element of 10, which is 30. So for 30, what will be placed? What will be placed after 30? Here will be placed the next greater element of 30. Okay, so after 30 actually there is 0, then 20, then 4. So there is no element greater than 30 after 30. Okay, so here, so this answer is this. So for this the next greater element is actually -1. So we'll place -1 if there is no next greater element. Okay, as we have done this for our previous example. So for 0 there is 20. So 20 is our answer, right? For 20 there is 4, which is not greater than 20, and there are no other elements. So for 20 also the answer is -1. 4 is the last element, it's -1. So our answer is 30 -1, 20 -1, -1. Okay, let's check our answer. 10, 30, 0, 20, 4. 10, 30, 0, 24. Okay, so answer should be what? 30 minus 1, 20 minus 1 minus 1. Is that what we have got? 30 minus 1, 20 minus 1 minus 1. Yeah, just same as we've done this. So let's now see how to solve this. Okay, it's very simple problem. So what we'll do is we'll create a stack. So stack is very useful when some operation is depending on the after elements or before elements. Okay, so what we are going to do at the beginning is first we are going to push the last element here, push last element, and secondly, so here is suppose our answer array that we will return as my result. Okay, so I have to return an array, right? So suppose this is the array of same size as my given array, so I'll place -1 in the last position. Why? Because for the last position the answer is always -1 as it has no next array element, right? So now keep a pointer here. So from and after that our work is actually starting. So what we will do, if my array element is greater than the stack's peak, I will do something, otherwise I will do something else. So let's say 2 is greater than 4. So 2 greater than 4 doesn't happen, so this part will work. So in the else part we'll push it into my stack, and before that I will push into my stack, right? But before that I will place here, as my pointer is currently in second last position. So in second last position I will place my stack's peak, which is 4. Okay, and then I am gonna push it, the I pointer pointing to that element, which is 2. So I'll push 2. Okay, so I'm gonna place the stack's peak and push the ith value of array. Okay, now my pointer goes to this element, previous element. So now 3 is greater than 2, that is my array element is greater than stack peak, so this condition is satisfied. So what I will do, I will keep removing the stack elements. I will keep removing stack elements until I get an element which is greater than my array element. So I am gonna popping. So I will keep popping until I got an element here in my stack which is greater than 3, that is array element. So I pop 2. Now my current stack's peak. So until this element means the stack's peak, current stack's peak is 4. So as there the stack size is 1, so there is only one element, so peak is 4. So my current element, that is my stack's peak, is greater than my array element. So I'll push this element here. I'll place 4 here and push 3. Okay, and so place the stack's peak in my array and push the array element to stack. Okay, push array element to stack. So I'm going to push 3. Now move here. So here is 1, here is 3. So array element is greater than 3. There is 1 greater than 3. No, 1 is not greater than 3. So array element is 1, stack's peak is 3. So 1 is not greater than 3. So this part will be executed. So place, so what we will do, place the stack's peak, which is 3, right? Place stack's peak, place 3, then place the ith value of array. Okay, so ith value is 1. Please push ith value of array. So push 1 here. Okay, then I goes here, I goes here. So the loop is terminated. Okay, so our work is done as our array is fully filled. So this is the algorithm actually. So you are noticing that this part, that pushing the array element into my stack is common. Okay, the thing is, in one case I directly push the value, I directly place my stack's peak to this array, and in another case I keep removing until a condition, then I place the stack's peak in this array. Okay, so here is two things we are doing for filling the array. Here is one thing for filling the array. Here is one thing for filling the stack. Here is one thing for filling the stack. So these two are common things. Okay, these two are common things. So for filling the array, this part is working. Okay, so let's code now. So what I'm gonna do is, we're gonna create a stack first. Stack of long, as the given array is in the long type, right? And then we are gonna create an array. Suppose the array name is answer, which will return of same size, and we are gonna push the last element, right? And so pushing the last element, and in the last position of our array I'm gonna place -1, right? So at the beginning I'm doing these things, push the last element, place -1, right? So after that our work is starting. Okay, so while my stack is not empty, and also my I pointer is greater or equal to 0, that is not exceeding or my array, right? So what I am doing, I am checking this condition. Okay, this array I greater than stack peaks or not. So just giving this size greater than 0, because I have to pop in the code, inside code I have to pop things. So whenever I am going to pop, I have to check this condition, the stack is empty or not, whenever I am doing this. Okay, doesn't matter I am doing this twice or thrice, because I am doing this once here and once here, right? So that doesn't matter actually. When I am going to pop this, I will do this condition, and my array element is greater than stack's peak or not, right? Greater than stack's peak or not. If it is greater than the stack's peak, okay, if it is greater than my stack peak, what I'm gonna do is I'm gonna keep popping, right? Or removing. So popping means removing. I'm gonna popping. So after that, the loop is terminated on based on two condition. Either my stack is empty or I get an element here which is greater than my array. Okay, so my this loop will terminate it only if this condition fails or this condition fails. So if this condition fails, then I got the element in the stack which is greater than my array element. I will just push it. That's okay. But what if my stack is empty? What if my stack is empty? If my stack is empty, so that means actually I got no next greater element. So I will place -1 here. Otherwise, I'm gonna place the stack's peak value. Okay. Nothing else. After that, I will push. That's what I'm doing here. I'm just writing these parts. Okay. See. So if this loop is not initiated anytime, so that means actually this condition happens, right? So in this condition, we'll place the stack's peak and push the ith value. So we place the stack's peak here and push the ith value. Push ith value of our array. And then I minus. So that's the thing I'm doing. And at last, I will return my answer. So I hope this works. Let's compile it. Sorry, it will be not -1. It will be answer dot length -2. So I pointer is starting from the second last element, right? 2. So that's why. Long cannot be okay. So I have created an integer array. It will be a long array. Yeah, so you got it. Let's submit it. Yeah, so you got it. Now I have to tell you something. This is the more or less code. The one thing is there that why I am doing this. So why I am doing the algorithm, why the algorithm works. Okay, so see that I am pushing the last element. I am doing the operations from right to left because I have to find the just right next greater element, right? So see that I pushed 4 here. I am starting from here. So after 2 there is 4, right? So after 2 there is 4. So my right things are already here. So I have to check that if the right parts of 2 is matching our answer or not. So 4 is greater than 2. So for 2 the next greater element is 4. I got it. Because I have only 4 here. The stack's peak. And for 4 the answer is -1. And then why I am pushing 2 here is because if I do not push 2, there may be an element. Suppose here, suppose this is 0 1 2 4. If I do not push 2 after placing 4 in my array, if I do not push 2, I am pushing 2, right? Then I am again checking for my this element 3, is this greater than that. Okay, so why I am pushing 2? Because suppose here is 1, so for 1 the next greater element is 2, and I am placing the next greater elements, I am placing the next greater elements from where? From this stack, right? So I have to keep my answer in the stack. If there is 1, the next greater element is 2, right? So if I do not push here, here will only be 4, here will only be 4, but 4 is not the next greater element of 1. So that is why I am pushing 2, because it may be the next greater elements of other element. This one may be the next greater element of other element before it, that's why. So I pushed it and I keep my pointer moving in the left side. So 3 is not greater than 2, so why I am popping this? Okay, so you got the logic for pushing the elements. In case of just we got the greater element here, so here is my greater element. Why I am popping this? Because I have to find the answer for this position, right? The position at 3. So at the position at 0 1 2 3, the position at 1, right? So what I am storing in the position of 1 in my array, suppose this is my position 1, right? So what I am storing here in position 1 of my original given array, the next greater element of that element in position 1. So I have to place here answer for position 1. So the at position 1 the element is 3, so I have to store the answer for 3. So that means I have to place here the next greater element of 3, right? So if this element is not greater, so if this element is not greater, I have to remove this, because this never gonna be my answer. So I have to check until I get an element which is greater than my 3. So I get 4, that is why I placed 4 here. Again I am pushing 3 here, because maybe 3 be the answer for some before elements of 3, right? And then I came here at 1, and 1 is not greater than 3, so for 1 the answer is 3, right? So I will just place 3 here and push 1 to here. So after that my ith pointer is coming in here, so the loop is terminated. So I got my answer. So that is the significance of doing these things, removing, popping, pushing, right? So this is just the structure of the thinking process of this algorithm. So if you like the video, then please like, share and subscribe. So let's see you in the next video.